Hello and welcome to AI for Developers. I'm Chaitanya talking bot. Today's lesson is titled Graph Neural Networks. GNNs. AI Understanding Connections. How AI analyzes relationships and networks. Like social graphs or molecular structures. Welcome to AI for Developers by Chaitanya. Today, we're diving into a super cool part of AI called Graph Neural Networks. Or GNNs. Imagine AI that doesn't just look at individual pieces of data, but actually understands how everything is connected. That's what GNNs do. We'll explore how AI analyzes relationships and networks. Just like understanding friendships on social media or how atoms bond in a molecule. No prior AI knowledge needed, we'll build from scratch. Most AI you've heard about works with simple data, like rows in a spreadsheet, pixels in an image, or words in a sentence. But what about data where connections are crucial? Think of a social network. It's not just a list of people, but a web of friends. Or a city map, not just a list of streets, but how they connect to form routes. This connected data is what we call a graph. A graph has nodes, the individual things, like people or cities, and edges, the connections between them, like friendships or roads. As developers, we encounter connected data everywhere, from database relationships to network topologies. So, if graphs are everywhere, why don't we just use our standard AI tools? The problem is that traditional AI models, like those used for image recognition, expect data in a very organized, fixed shape, like a grid of pixels. But graphs are messy. They don't have a fixed size. A person might have 10 friends, another 100. There's no clear top left or bottom right. This irregular, dynamic nature of graphs makes it incredibly difficult for standard AI models to process and learn from them effectively. It's like trying to fit a flexible, sprawling tree into a rigid, rectangular box. This is where graph neural networks, GNNs, come in. Think of GNNs as a special type of AI model specifically designed to understand graphs. While other neural networks excel at sequences or grids, GNNs are built from the ground up to handle the unique challenge of connected data. Their superpower is not just looking at individual nodes or edges, but understanding the context and relationships between them. For a developer, this means unlocking the ability to build intelligent systems for truly relational data. Imagine each node in our graph, e.g., a person, as having some initial information. How does a GNN learn? It uses a clever trick called message passing, which is like a neighborhood gossip network. Each node talks to its direct neighbors, gathers information from them, and then combines that information with its own. This process repeats over several rounds. So, in the first round, a node knows about itself and its immediate friends. In the second round, it also implicitly knows about its friends of friends, and so on. By gossiping with its neighbors, each node builds a rich, contextual understanding of its place and role within the entire network. This aggregated, learned representation is what the AI then uses for predictions. GNNs are powerful problem solvers across many industries. 1. Social media. Recommending new friends or relevant content by understanding your network. 2. Drug discovery. Analyzing how different molecules, which are graphs of atoms, interact to find new medicines. 3. Recommendation systems. Customers who bought this also bought, by understanding product relationships. 4. Fraud detection. Spotting suspicious patterns in financial transaction networks, where fraudsters often form small, tight-knit groups. 5. Traffic prediction. Modeling road networks to predict traffic flow and optimize routes. From a developer's perspective, GNNs allow you to build AI that goes beyond simple classifications to truly understand complex system behaviors. As a developer, understanding GNNs is a significant skill. It allows you to 1. Solve new problem types. Tackle intricate problems that traditional AI couldn't handle because of their relational nature. 2. Build smarter systems. Create applications that offer deeper insights and more intelligent interactions by leveraging connections within data. 3. Stay ahead. GNNs are a rapidly growing field with immense potential. Learning them now positions you at the forefront of AI development. 4. Accessible tools. Just like other AI, there are powerful open-source libraries, e.g., PyTorch Geometric, DGL, that abstract away the complex math, letting you focus on applying GNNs to your specific problems. You don't have to build them from scratch. You can use them to innovate. Thanks for watching. If you found this helpful, make sure to subscribe to our channel and hit the like button.